Hey everyone, welcome back to the channel Code with AKJ. Today is day 7 of solving LeetCode 75 challenge, and today's question is product of array except self. So the question says here, given an integer array nums, return an array answer such that answer of I is equal to the product of elements of nums except nums of I. The product of any prefix or suffix of nums is guaranteed to be fit in a 32-bit integer, and you must write an algorithm that runs in O of n time and without using the division operation. So here we are given an array nums, and we need to create a new array called answer, where each element answer of I is the product of all elements in nums except nums of I. So the catch here is that we are not allowed to use the division operation, and our solution must run in O of n time complexity. So here for an input nums 1, 2, 3, 4, the output should be 24, 12, 8 and 6, where the product of the elements should be considered except the nums of I. So here initially the brute force approach would be straightforward. That is, for each element I in nums, we'll calculate the product of all the elements except this nums of I using nested loops. So let's understand the brute force approach here. For example, nums array is 1, 2, 3, 4. So brute force approach says that we use two for loops to find the product of all the elements except the nums of I, and in this way, using for loops, we'll find the product of all the elements except the nums of I for each element I here. So since we are using two for loops, the time complexity here would be O of n square and space complexity would be O of 1, which is efficient for smaller arrays. So let's move on to the code and let's see whether it gets accepted or not. So this is a brute force approach code where we have taken a new array vector initialized with size of the nums array, and initially all the values would be 0. I've taken the size of the nums array and I've used two for loops to calculate the product of all elements except the nums of I, where I've written this particular condition where if that particular j index is not equals to I, then we'll calculate the product of those elements. And finally, after calculating the product value, we'll update our new array value with our product answer, and finally we'll return that new array. So let's run this code. So let's submit. As you can see, this approach gives us time limit exceeded, as here the time complexity is O of n squared due to two for loops, and the space complexity here is O of n, as we are using the external data structure. But that's not the problem here. The main problem here is to reduce our time complexity from O of n squared to O of n. So in our optimal approach to achieve O of n time complexity, we'll use two additional arrays, which is left array and right array. The left array stores the product of all elements to the left of index I, and right array stores the product of all elements to the right of I. So here the step would be to generate and build that particular left array and right array, where left of I will represent the product of all elements till this particular index I, and right array will represent the product of all elements to the right of I. And finally we'll multiply both left of I and right of I to get our answer of I. So this is a code for the approach we have discussed and try run with this particular nums array. So here initially I've taken the size of the nums vector and I've taken two additional arrays left and right, which would be initially with value 1 here, and I've taken the answer vector to store all the required answers. I've filled the left array and right array, where the left array will calculate the left array values by iterating from index 1 till n and calculating product of values considering the nums of I minus 1 and the previous left array value. And finally the same way goes with right array, where we iterate from the end of the array from n minus 2 till the index 0, and same step would be followed here to fill this particular right array. And finally, to calculate our answer vector values, we'll multiply these two product values from these two respective arrays, which is left of I into right of I. So in this way we'll get our required answer, which is the product of all the elements except value at index I. So let's try to run this code. So let's submit. As you can see, this approach gives us a successful submission Here the time complexity is O of n and space complexity is O of n. So let's try to further optimize it, and let's not use any additional array, which is also our follow-up question. That is, can you solve this particular problem in O of 1 extra space complexity? So here, as we know that the problem gives us an array nums and asks us to return that new array where each element is the product of all other elements except the one at that particular index I. So here the trick is, if there are zeros in the array, which is you can observe in the second example, so we need to handle them carefully to avoid any invalid calculations. So in our optimal approach to handle these zero elements as well, in this approach what we'll do here is to calculate the product of all the non-zero elements, and the second step here would be to handle different cases based on the count of zeros, which you can easily observe from this particular example. Here I have taken the nums array where the values are 1, 2, 3, 0 and 4, and we'll calculate the product of all the non-zero elements. Here the product would be 1 into 2 into 3 into 4, which is 24 here. And finally we'll also count the number of zeros, which is count of 0 is 1, and we'll have three main conditions based on the count of zeros to assign all these product values to each and every particular index I. So what we'll do here is, first we'll calculate the non-product elements and we'll also count the number of zeros, and we'll assign all these product values based on these three conditions. So if the particular index value is non-zero and we have number of zeros is equals to 0, that means that particular array does not have any zeros, and we'll directly can assign that product value divided by that particular nums value, which is product by nums of I. Our second condition would be if that particular nums of I is 0, which you can observe that this particular index, and the zero count is also 1, which means this 0 is only the 0 present in the whole array, then we can easily assign the product of non-zero elements, which is 24 here, to this particular index I. And finally, if it does not satisfy these two conditions, we can easily say that there are numerous zeros in this particular index I. We can directly assign 0 here. So here the time complexity would be O of n and space complexity would be O of 1. So in this way, we have optimized both our time complexity and space complexity. So let's move on to the code and let's submit. So this is a code for the approach we have discussed, which is optimized both in time complexity and space complexity. Here I have taken the product variable, which is initially 1. I have counted the number of zeros in this whole array using count function. So I have calculated the product of all non-zero elements, and based on these three conditions, we have assigned the product values to each and every index I. So if that particular nums of I is non-zero and the count of 0 is 0, we'll directly assign that particular index with product by nums of that particular value. And if not, if the current index value is 0 and count of 0 is less than 2, which means only 1 0 in the whole array, then we can easily assign the product of non-zero elements. And if not, we'll directly assign 0 to that particular index. And finally, we'll return our nums array, which is our resultant array. So let's run this code. So okay, so let's submit. As you can see, this approach gives us successful submission. Here the time complexity is O of n, as we are using a count function to count the number of zeros, as well as using O of n time complexity to calculate our product value. And space complexity here is O of 1, as we are not using any additional array or any kind of data structure here. And that's it, guys. We have successfully solved this product of array except self problem, moving from a brute force approach to an optimized solution with O of n time complexity and O of 1 space complexity. So if you enjoyed this video, please give it a thumbs up and don't forget to subscribe for more coding solutions, and let me know in the comments which approach did you like the most. Thanks for watching, and I'll see you in the next one.